And now we come to Chapter 5 Summary. So let's take a look at the Chapter 5, which is on page 135. The concept map. Now, in here, we know that the energy can be divided into 6 different kinds. So we got sound, we got kinetic, we got chemical, potential, and we got light and thermal. So there are 6 kinds of energy that we talk about. And under the heat transfer, which is the thermal energy, we got 3 different types of transfer. We got the conduction, which is by touching, and convection, which is by moving of the particles in the fluid, namely liquid and gas. And radiation, the last one, it does not require anything, which means that it can be done in the vacuum. So there are 3 different kinds of heat transfer. And for conduction, you have to be careful because all 3 things can happen. It can happen in solid, it can happen in liquid, or it can happen in gas. So in these 3, especially for conduction in liquid, for example, the liquid, when it touches a surface, let's say it's a hot surface, it will convert that from conduction into convection. So basically, at the very beginning, there's conduction. The liquid will be touching the hot plate, and then it will become excited, or more energy is being transferred to the liquid. After that, in the liquid, it will have convection. And we talk about convection current, what that is. So if you're not sure, please refer to the PowerPoint that we have talked about. Now, under energy, we have studied the law of conservation of energy, so that you know that this is a statement. It can be converted from one form to another, but it cannot be created nor destroyed. So basically, energy is already there. It just changed from one form to another. That's what it means by the law of conservation of energy. Now in here, we also talk about from different types of energy sources, and we divide it into non-renewable and renewable. So under non-renewable resources, we have the fossil fuel, which is a big one, and it contains coal, crude oil, natural gas, and I also mentioned about the methane as well, methane hydrates, and which is the solid form of methane. And then also under non-renewable, we got nuclear energy, and we talk about some of the examples in nuclear accidents. So it's just something you need to be aware of. And even of today, Chernobyl, which happens more than 20 years ago, it still have the lingering effects of the radiation of today. In Japan, of course, is just in recent years, it still have a lot of effects on the food productions, and the people around there are affected by the radiation as of today. And in the renewable resources, we talk about solar, wind, hydroelectric, and biomass, all these 4 different types of energy sources. And now we can go on to the unit summary to take a look at, just a quick look at what we have talked about in each session. And in Chapter 5, there are 4 big sessions, and in 5.1, we look at different types of energy here. Again, there are 6 types. And number 2, we have talked about joules and calorie. And in science, we mainly use joules. In calorie, it's more for nutrition, or in the food science, we talk about more calories. But mostly in physics in general, we use joules or kilojoules for that matter. Now in here, in 5.2, we talk about the energy conversion. So we talk about from one form change to another form, and we know that it cannot be created nor destroyed, and we give it the name, the law of conservation of energy here. And also in this part, we use a diagram, the Sankey diagram, to represent what is being used, how effective is the process of transferring one energy to another, The efficiency is shown by this equation. In here, you see that this is a general equation. The efficiency is equal to the useful output energy over the input, the total input times 100%. Now, if you remember in primary school or next year in Form 2, you will realize this equation. When we talk about percentage, we will always use this kind of equation. The total amount is at the bottom as the denominator. And in here it's multiplied by 100% to give you that efficiency. And next, we move on to heat transfer. Again, there are 3 types. The first type is conduction, which conduct food by touching from the hot end to the colder end. And in here, one generalization is metal generally is a good conductor of heat, and non-metals are poor conductor of heat. And water and air are poor conductor of heat. Remember that water and air are poor conductor of heat. Actually, that might be counterintuitive to what you normally see, but actually both of them are pretty poor conductor. And in the second form of heat transfer, we got convection, which is conducted by the movement of liquid or gas. We generally call that as a fluid. And in here, the convection is by the moving of this movement. We have a name for it. We call that convection current. And that's shown in this diagram. You see that that is the convection current. From the hot end going up, and then as it rises, because the density is lower, and then you go to the top and start to cool down, the density increases, and then that's why it will come back down. And then in here it's showing you in a 2-dimensional way of this current, but it's happening in 3-dimensional, meaning that it's going around the whole pot in a circle, more like a donut. And in here, the last but not least is radiation. So in here, again, if you're standing next to the heat source and you can feel the heat, but it's not there's no movement of air, it's not by convection current, then it is giving out the heat by radiation. And yes, everything gives out radiation, every single thing. The question is the amount that's giving out. And some of it, if it's giving out a lot of radiation, that would cause cancer. And most likely, if you go to the space and there's nothing to cover you with the protection of the atmosphere, then you will be exposed to the radiation. That will be a bad thing. And in here, you need to know what kind of surface is good for absorbing and emitting radiation. And actually it's dull and black. Dull is the surface that is touching it, and then black is the color. So basically these 2 things, it consists of a good absorber of radiation. At the same time, it's also a good emitter of radiation. And the opposite is true. Shiny and silvery surface, a poor absorber of radiation and also a poor emitter of radiation. Next, we talk about the energy source in a bit more details. And in here, we talk about the fossil fuel as a non-renewable resources, because we can replenish it in our lifetime. We cannot make more fossil fuel. And in here, once it's limited, once you use it up, that's it. We cannot have extra ones coming from the fossil fuel. Now, many harmful substances are emitted when we burn the fossil fuels. Especially we focus on carbon dioxide because it's a greenhouse gas. But besides that, there's a lot other pollutants. We didn't talk about it in this chapter, but we have talked about it in the past. And the NOx and SO, NO, all those things come out from burning the fossil fuel. And it causes a lot of health issues and also the environmental concerns. Now, number 16, we have the nuclear power. It is also a non-renewable resources because once you use it up, you cannot replenish the nuclear, the plutonium. We cannot make it in our lifetime to continue making it. We cannot do that because it's limited. Now, as you remember from the famous scientist Albert Einstein, he actually mentioned the E equal to mc squared. And in the nuclear power, actually that's what it's doing. It's converting the mass into energy. That's what it's converting. And it's not close to what Albert Einstein predicts that, because if anyone can actually achieve it, then the amount of energy released can be even more than what you're seeing in the nuclear power plant. And of course, with the nuclear power, you got the waste. And that's not many nations that can cheat the waste as of this point. Only France can, if I remember correctly. Now, number 17, the renewable resources that can be replenished. And in here, it generally produces less pollution because it's a continuous process. It's more renewable, and then it will just keep on making it. And in here, we see that solar, wind, hydroelectric, and biomass are some of the general examples. It's not limited to this, but that's what we talk about in this chapter. So in here, we talk about solar energy. And solar energy relies heavily on the solar panels. And we need to know that how efficient, using the Sankey diagram, we'll be able to tell you that how effective are the solar panels in converting the solar energy into electric. So that's what we do, okay? And in here, it says this equipment is expensive. The price is coming down as we talk about, and one of the biggest manufacturer of the solar panel is China. So that's one reason why that in Hong Kong we can benefit from getting the cheap equipment from China. On the other hand, you need to balance it. Is it reliable, the quality control and all those things? It comes in as the service life of the machine itself. So you need to balance it, okay? Now, in here, the wind power. Of course, you know that the wind is continuous, and it depending on the speed, because if you have typhoon or the typhoon signal 10 or 8, it's useless. Those winds are too powerful. We cannot harvest the high speed as of today's technology. Maybe later on you can think of a new way of capturing those type of energy, because those type of energy, if you can capture it, basically it has the power of explosive TNT. It can be used in other ways as a weapon as well. So you need to be aware of that. Now in here, we generally use the wind turbine to generate electricity. And as the wind turbine turns, the blades will be it will be especially dangerous for the animals. For the birds, for example, if it flies by, it will just knock down the birds. The birds sees it and it just got hit by it. And actually, the noise level, if you're living next to one of these turbines, it can be relatively noisy because the turbines are turning and you can hear it, and people don't really like that, and nor the way it looks, because people like to look at the natural environment as it is, but sometimes that's what people have to live with. And we got the hydroelectric power. That's the Three Gorges Dam, and I talk about in my lecture about the Africa's Ethiopian dam project as well. And maybe in your lifetime you will see less of the dam project, because the dam project actually, people are starting to realize that it damages a lot of land and the water habitats. For example, the fish cannot go back to where they were born to spawn and give birth to the next generation. So people are starting to realize that's happening. And next, we got the last one, the biomass energy. In Singapore, it's doing a great job of burning this biomass. In Hong Kong, we are not. And it's in a general idea that if you actually look at it, biomass just means that any plants that grow out of the land and you can cut it and then basically use it as a fuel to burn it. That's what it means by that. And in Canada, they don't really do that. After they cut it off, they don't burn it. They just chop it into smaller pieces. For example, a log of wood, they would just make it into wood chips and place it back on the earth, and so that the tree itself can absorb the nutrient directly without burning it. Of course, if burning it, it will generate the power to use it somewhere else. Now, the key terms you should be aware of, okay? So it's not too exciting, but you should know these words by now. We spent last 2 to 3 weeks talk about these terms here, so I'm not going to spend too much time on it. And we'll go to the unit exercise. Okay, so in here, the first question, the energy stored in food is called chemical energy. Is it true or false? It's true. Now, for some reason, I cannot show you the next one, so I have to go out of this page and show you like this. Oh, okay. So the second one, let me see if it works. Okay. So in here, 1 joules of energy is equal to 1 calorie energy. Is true or false? Yes, false. In here, actually, 1 joules is about 0.2 calorie, 0.239 calorie to be exact. But in here, if you think of it, it's a conversion. It's 0.2. It's pretty good. Now in here, the conduction does not take place in insulators of heat. Is it true or false? Give it a second, think about it. Does not take place. Does it take place or does it not take place? False. It can take place. So conduction does take place in insulators, but not very good, not effective, that's all. But it still happens. That's why it's false. The sun transfers heat to the earth by radiation. True or false? Is pretty obvious. It's true, because there's nothing between earth and the sun. It's vacuum. But as you know, I always mention that when there's vacuum, there is the dark matter behind it. How does it work? We don't know. So it's up to you to find out. Now, in here, number 5, nuclear power is a kind of renewable energy source. True or false? False, because it's non-renewable. Okay? Now, in here, we got the MC question. When the television is switched on, which form of energy is electrical energy converted into? So what do you see over there? So in here, do you see your TV moving? So it's not kinetic for sure, so B is out. And in here, do you see any other chemical being generated? And as far as I'm concerned, no. So in here, only A is the correct answer. Number 2, and in here we got a roller coaster starting from A, going down, B is in the middle, C is the bottom of that curve, and then D is the very end, it comes to west. In here, make sure you know that the word comes to west, what does that mean? Okay. Okay, never mind. Okay, so in here, let's carry on. Now, it comes to west means that the thing is not moving, the roller coaster is not moving at all. So let's take a look. Now, at which point does the roller coaster has the greatest amount of potential energy? Remember, potential energy means that it is not moving. So in here, which point is it not moving? So in here, we got A and D. It's not moving, and A is a lot higher than D, so that's why, because of the height difference, it would have more potential energy at the point A. So in here, the answer is A. Next question. At which other point does the roller coaster has no kinetic energy? Remember, no kinetic energy means that it is not moving at all. So in here, which point is it not moving? In here, in this diagram, which point is it moving? B and C are moving, so we can cross out those. So in here, only A and D are not moving. So in here, in this question, has no kinetic energy. Yes, the answer B, because at point A and point D, those 2 points is not moving at all. Now we've got a cooker has an energy efficiency of 80%, and if it has 500 kilojoules of useful output energy. Now in here, remember, useful output means that this is the output that we want, the desirable one. So in the equation, we put 500 kilojoules on top. Okay? So in here, we do not know what is the input. So the denominator is X. We don't know what that is. And 500 kilojoules over X equal to times 100% equal to 80%. So in here, we need to do the change of turns. And if you look at the answer here, just looking at the answer without doing any calculation, we know that for sure the input energy has to be more than the output energy. So the answer has to be more than 500 kilojoules without doing any calculation. Because we know that the efficiency is only 80%, meaning that 20% is lost. So the 20% have to add back into the 500 kilojoules we have, meaning that in here, A, B, and C are all wrong. All of them are lower than 500 kilojoules already, without doing any calculation. We can look at the answer and say that, okay, only D is the reasonable answer. So the answer is D. Okay, again, you should sit down and do the calculation once and make sure you know how to get this done. But if you have get a hand of how to do the equations on the efficiency already, then you look at the answer. You can come up with the correct answer by looking at the answer already. Because the input has to be more than the output. Okay, number 5. In here, which statement best explains why the handles of this kettle are usually made of plastic? Okay, so what is the reason for that? Why do we use plastic? Why don't we just use metal as the kettle itself? So what is the property of the plastic? Does it absorb heat? Yeah, it absorbs some heat. Is it cheaper than the metal? Is it cheaper than metal? Is it a good conductor of heat? No, it's not. So that's why it is a poor conductor of heat. Only D is a reasonable answer. Even though A and B are correct, we know that the plastic will absorb some heat. It just melts, that's all. And for B, it's cheaper than metal. Yes, it's cheaper. That's why you got a lot of plastic bottles. We don't have a lot of metal cans that contains liquid. So you would not see that, for example, you buy 2 liters of water, you will rarely see that it's contained in a metal. It's always contained in a plastic bottle. That's the reason why. It's cheaper, that's why. Okay, number 6. In here, which container below can keep the same amount of water inside heat for a longer period of time? So in here, we want to keep it to be a longer, extended period of time. So in here, we can look at the lid. It has a lid on, so basically it will stop it from the convection. So in here, we can just eliminate B and D directly. So in here, we got answer is either A or C. So let's take a look at A and C. In here, A is made of the dull black surface. So in here, actually, it absorbs better, but also it will radiate better. So we are not giving it any more heat. It just have hot water inside. So it will start to radiate out of this black dull surface faster. So in here, A will lose more heat. So that's why only C is the correct answer. in this case, because C would keep the heat inside the bottle. Okay? See if it makes sense to you. Think about it, what I'm talking about. The first step, I just look at it and say, oh, okay, there's no lid on it, so that it will be losing the heat by convection currents. So B and D are out. So we only look at A and C with the surface color. So in here, black is a good emitter and good absorber. Since it's not absorbing anything, it's emitting. So in here, it will lose a lot more heat in A than C. So that's why C is the correct answer. And in question 7, which of the following statement is the advantage of using solar energy to generate electricity over coal? So if you look at the solar energy, you know that it is a renewable resources compared to coal is a non-renewable resources. So in here, number 1 is correct. It can be replenished in a short period of time. That's the definition for renewable resources. And number 2, solar energy causes less pollution than burning coal. Of course, if it generates more pollution, why do we use that at all? It's more expensive anyway, right? So in here, number 1 and number 2 are correct. So let's take a look at number 3. No special equipment is needed to convert solar energy into electricity. That's wrong, because we need the solar panel. Then solar panel is actually expensive, relatively speaking, right now. The price keep on dropping in the recent years, but it still takes some time to recuperate the amount of money you put into the solar panel. Couple of years. It used to be tens of years. Right now it is getting shorter and shorter in the return to the break even point. Okay, so in here, only 1 and 2 are correct, so it is B. Okay, in the question C here, the question 1, we've got this kind of lampstand. Actually, it generates a lot of heat. It's a heater. So the heat will burn on the top, and then it will be coming from the hood, coming back down. Okay, so let's take a look. Now, name the process of which the heat is transferred from the heater to the surrounding. Now, in here, actually, it's not by convection, it's by radiation. Because convection actually means that the heat will be going up. If you're sitting below it, then how can the heat be getting from the heater to you? It's only through radiation, and please do not touch it. It will be connecting too much energy to you by conduction. So in here, it's done by radiation. Now in here, explain why the inner surface of the hood should be a shiny silvery surface rather than a dark surface. So think about it. If it's dark, it means that it will absorb the energy, but you don't want that, right? You want it by using the radiation so that it will bounce off it, so it will not absorb by it. If it's really black surface, it will just keep on absorbing more and more heat, and then you are defeating the whole purpose of using a heater, because the heater are generating the heat and you're not getting it. It just doesn't make sense. So in here, that's why it's silvery surface. The radiation will be bounced off the silvery surface to you, so it will reduce the heat loss that way. Now in here, you need to draw the Sankey diagram. So please take a look at this question and figure out for each square how big is the unit should be, because in here the input is 15 kilojoules. So I give you a hint, each square should be 1 kilojoules for 1 square. So you have to start in the graph somewhere in the middle, so that you would not be running out of space when you turn from the middle to the bottom as the waste energy. So in here, 3 kilojoules is converted into light, and then the remaining 12 kilojoules in here is converted to thermal. So in here, thermal energy, the heat energy, is the desired energy, the useful energy. So in here, the outcome of 12 kilojoules is what we want, and only 3 kilojoules are lost as the light energy, so you see as light. So in here, you draw this diagram properly, please use a ruler. That's what it should look like, okay? So in here, each of the square is representing 1 kilojoules. So for the input of chemical energy of 15 kilojoules, there are 15 squares on your left. And then on the right, we got 12 squares because the thermal energy, the desirable outcome, is the thermal energy, only have 12 kilojoules. So where's the other 3 squares, the 3 kilojoules, is converted into light energy, so it just go down that way, okay? So you can you ask me, what's the length of it? It doesn't matter, as long as the width is the important one. I'm telling you that what is the conversion rate. And yes, you can go home and figure out what is the efficiency of this heater as well. Should not be too difficult. When you remember the efficiency is equal to the output, desired output over the input times 100%. Okay, and that's the end of this lesson on chapter 5.